the other day. Okay, so, and I'll just do it on this page and I'll share this with you later in case, and since someone else had created this for me and shared it with me. So go ahead and tell me what your question is.
Okay, so this is a question off of my homework. It says, for what values of k is the line y equals 4x minus 9 tangent to the graph of f of x equals x squared minus kx?
Okay, so for what values of k is this line tangent to this? All right, so here's the key. Tangent, whenever you see tangent lines, you need a point which is on f of x and a slope which is found by using the derivative. Okay, when we have the point and the slope, then we have the tangent line. So the tangent line right here says, for what values of k is this tangent to this graph? So let's find the derivative first. So the derivative of this is just going to be 2x minus k. You understand how I came up with that?
Mm-hmm.
Okay, so there's the derivative for it. And it says, for what values of k is that equation tangent? So this equation, if that's a tangent line, then it's got a slope, which is 4, right? And remember that slope comes from the derivative. So I'm going to plug 4 in for this, and then I'm going to solve it for values of x. Let's see. I'm going to solve this. So there's for values of k is that tangent to that. Okay, so I don't know what x is yet. Okay, well, this is a different kind of problem than I've seen before. So let me just think about this for a second.
You're totally fine. It was, my teacher said that it was like a problem question.
Mm-hmm, like a bonus type thing.
Yeah.
Yeah. I think we might have to do a system of equations possibly. So we know that I'm going to have some equation. For values of k is that tangent to that. So we know that the slope is 4. And I know one of the points is 0, negative 9. And that's on the actual function. Okay, so now I'm going to plug this into f of x. That's what I'm going to do. So f of x equals negative 9 when x equals 0. Is that possible? The point on the original, let's see. Okay, no, because I don't know what the point is. No, that's not going to work. Let's try to work backward. So what we usually do is we have this y minus y1 equals m times x minus x1, right? And these two things are the point x1 comma y1, which is on f of x. You understand what I'm saying?
Yeah.
That's on the actual function. And then this is the derivative, or this is the derivative at x sub 1. That's what that is. So we want to work backward to find what values of k is that line tangent to f of x. So The problem is I don't know what the point is. So I have to see where those in. Okay, yeah. So here's what I think I might need to do. I'm going to change colors for this little segue of what I'm going to do. I think what I'm trying to do is find out where this intersects with this, because the tangent line, that point is on that equation and on this function. So 4x minus 9 equals x squared minus kx. I think that's what I have to do. And now let's solve this. So x squared minus kx minus 4x plus 9. So x squared, if I factor out an x, it's going to be minus x times k plus 4 plus 9. So what's this going to do for me? This is going to find the point. There's going to be two solutions for that. That's going to be the point where it intersects. Value k tangent. And I would, let's see. How can I solve that? I mean, I can use the quadratic formula, I guess. Negative b. So negative b would be positive k plus 4. I'm using quadratic formula. I'm not sure if this is going to work. I'm just going down a rabbit hole. So negative b plus or minus the square root of b squared. And remember, b is negative.
Mm-hmm.
B is negative k plus 4. So that's squared minus 4ac all over 2a. So k plus 4 plus or minus the square root of squared. That's just going to be k squared plus 8k plus 16 minus 36 all over 2. I don't know if this is getting me anywhere. This is k plus 4 plus or minus the square root of k squared plus 8k minus 20 all over 2. So those are my solutions. So those are my possible solutions, the possible points that where, but that's for, we don't know we don't know the values of k that it's going to be yet.
Yeah.
We just know that those are my x values. So then maybe, but we also know that we have this right here. So we have x equals this and x equals that. So I guess we can solve for x. Again, this maybe I might be going way in the wrong direction or making this way harder than it has to be.
No, you're okay. Don't worry about it.
And I also could be doing this wrong. But that's what x equals. And so if I plug this in to here, if I set them equal to each other, then I can try to solve. So, and again, I'm running out of room. So let me do it over here. Now I'm going to set that equal to that. So 4 plus k over 2 equals k plus 4 plus or minus the square root of that mess all over 2. So let's just multiply both sides by 2. So that gets rid of that. Let's subtract k from both sides. Let's subtract 4 from both sides. So that gets rid of that and that. So I get 0 equals plus or minus the square root of k squared plus 8k minus 20. Now I square both sides. Because squaring 0, right, is just going to be 0 equals. So basically k squared plus 8k minus 20 equals 0. And now, yeah, does that factor?
Yeah.
K 10 and 2? Positive
10 and negative 7. Yeah.
Oh, wow. This might work. So k equals -10 or k equals +2.
I think so.
Is that the right answer?
Actually, yeah, it is.
Wow.
Yeah.
What
I
a
yeah.
problem. I'll be honest with you. There might have been an easier way to do that. I don't know.
It's
I've never
I
done a problem like that before. I was pulling out all the tricks I could find, and I'm pretty good at algebra. So
yeah. I'm gonna be honest. I I really like my math teacher as a person, but like sometimes he just goes too fast and like all he told us about this problem was like, yeah, you set up two equations to like be equal to each other. And like that was kind of it. And I was like, okay. Good to
oh wow.
know.
Well,
Yeah.
again, I don't know. I might have taken the long route on that. I might have gone a lot. Maybe we didn't have to go that far, but I think that worked. I mean, it worked. We can check if it works by plugging in 10 and plugging in 2 and seeing if those work. You know, you plug in, I'm sorry, -10 here. I'm sorry, K, -10 here. Well, let's see. We still have to figure out find the value of K for which that is tangent to that line. Like that was the trick. It was like, where does this line and this intersect? Because
Right.
oh, you know what? Maybe we could have factored this. Maybe if we factor that, there was an easier way to do that. If we
Maybe.
took an X out and made it X minus K, then you can see that it's going to be like, you can do it more like from a visual standpoint. So one of the points is 0 and the other point is X minus K. The other point is K right here. So this is a parabola like this. And then if you take this equation, I'll do this in yellow, and you graph that equation is going to go through -9. So right here, -9 and 4 is the slope. So that equation is going to do that. So it's just a matter of what the thing that K is going to do. It's going to change this K is basically going to change where this point is. It could be out here, it could be out here, it could be out here. So you're basically taking this yellow line and you're trying to make K the perfect number so that when you move it, because this 0, this is not going to change, right? K is the thing that's going to be changing. So that's basically this 0 is moving, and it could even move over here. So one of them was right here. That was one of them. And the other one was actually probably over here. Like that. You get what I'm saying?
No, definitely, yeah.
The other one would be probably like right here. So there's the two parabolas that have that yellow line as the tangent line. So there might have been I'm sure there was an easier way to do it, but I don't know what it is. I just did it in kind of the most practical way that I could think to do it. But like I said, there might have been an easier way. Probably was.
Yeah, sorry for giving you such like a hard one on the first one.
Yeah, that was tricky. All right. Well, we don't really have much time. Do you have another question for me, or do you want to just go ahead and watch those videos on your own?
That was my major question for now, so I'm okay if we just kind of leave it there and I watch the video, but
Yeah. So
yeah.
go ahead and watch that video, and I think that'll also. It seems like you have a pretty decent grasp on it, but really, for all these problems, the trick is really getting that algebra and knowing, not getting stumped by